Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about the definitions and terminology related to the Module 1 syllabus of Computer Organization and Architecture. So here comes the first definition. What is the computer? Define computer. Computer is an electronic machine which accepts data from the user as an input, processes it by doing some kind of manipulation and produces the output in a desired format. So here basically the computer can perform three functions: input, process, output. The input can be taken from the user, and after taking the input, processing can be done with the help of arithmetic and logical instructions. After processing, whatever the result produced as the information is referred as output, and it can be represented to the user in an understandable and desired format. So it is computer is an electronic machine which accepts input from the user, processes it, and produces the output at the desired format. So technically, a computer is a high-speed electronic data processing machine. To support the basic three functions, input, process and output, majorly three basic units are available in the computer. That is input unit, CPU, output unit. Input unit supports the input. It takes or receives data from the user and supplies it to the central processing unit in a machine readable form. So here user to machine interaction can be provided with the help of input devices. Variety of input devices are available like keyboard, mouse, MICR, OCR, OMR, barcode reader, etc. Whatever data that is supplied to the central processing unit, the central processing unit performs the processing activity of the computer. So here the central processing unit again consists of three subunits. They are control unit, arithmetic and logical unit, and memory unit. The information, the data, programs, instructions that are given to the system can be stored in the memory unit. The storage capacity of the system can be provided with the memory unit. In the processing, what are the intermediate results that are produced, and the output can also be stored in the memory unit. Variety of memory can be available, basically RAM and ROM. In the RAM, again it is categorized into static RAM and dynamic RAM. The ROM can be categorized into maskable ROM, EEPROM, PROM, E-square PROM. So RAM is random access memory which can support both the read and write operation, but the ROM can support only the read operation. And here the arithmetic operations like addition, subtraction, multiplication and division, and logical operations like and or not can be performed with the help of arithmetic and logical unit. So the basic computational capacity and decision making capability can be provided with the help of arithmetic and logical unit. The control unit generates the control signals that can monitor and manage various units that are connected with the computer. The coordination among the various functional units can be achieved with the help of control signals that are generated from the control unit. Next, third activity that is supported with the computer is the output. The output unit receives whatever information that is generated with the help of the processing capacity of the computer. That result can be displayed or can be presented to the user in a desired format with the help of output unit. Variety of output units are available like the printer, video visual display unit, speakers. So all these are varieties of output unit. So the output unit provides the computer to user interaction. So these are the basic functional units of the computer. Next, define register transfer language. The microprogram is collection of micro instructions. These microprograms can be stored in the control memory or the ROM. So here, these micro instructions can perform micro operations. The register transfer language, in short, can be specified as RTL, is a symbolic notations used to describe the micro operations and transfers among the registers. So, what are the micro operations that are performed can be symbolically notated with the help of RTL, register transfer language. So, in between registers, how this data can be transmitted, that is symbolically notated with the help of register transfer language. What are the basic notations that can be used in the RTL? Majorly, the RTL symbols are letters. So, the capital letters can be used to denote the registers that are involved in the transfer activity. So, here in an example, MAR, memory address register R2, the register R2 can be used in the RTL. So, the registers that are involved in the data transfer activity can be denoted with a letter. Next is parenthesis. Denoted a part of a register. For a 16-bit register, 0 to 7 bits generally considered as L, that is lower bit part of the register, and from 8 to 15 bits are generally considered as higher part of the register bits. Those can be represented with a parenthesis. So here R2L. That means in the register 0 to 7 bits can be considered for here can be represented in R2 parenthesis L. And in the register R2, 0 to 7 bits can be indicated like this by specifying the number separated with a hyphen. So we can represent R2 within parenthesis L or R2 0 to 7 bits. So to represent a part of register bits, the parenthesis can be used. Next, the third notation is arrow. Arrow is used to denote the transfer of information. So here, from the what is the value stored in the register R1 is transferred to register R2. So the data transfer, the direction of transfer can be represented with the arrow. Next notation is comma. Comma is used to separate two micro operations. If it are sequence of micro operations can be denoted, those operations can be separated with a comma. For example, consider here two micro operations are carried out here. The value stored in the register R2 can be transferred to the register R1, and the value stored in the register R1 is transferred to the register R2. So these two micro operations can be separated with a comma here. So these are the four notations that can be used in the RTL. How these notations can be used to specify the micro operations. The first example can be used to denote simple transfer. So the value stored in the register R1 is transferred to the register R2. The second example is conditional transfer. So here the control function is used for the conditional transfer. Here P is a control function. So it is a Boolean variable which can have either 0 or 1 value. If the condition, that is the control function, holds the value 1, then only the micro operation that is specified after colon can be executed. So the control function colon, the sequence of micro operations can be specified. The control function is a Boolean variable. So depending upon the control function value when 1, then the operations that are specified after colon can be executed. So here when the P is a control function, when P is equal to 1, then only the transfer of data from the register R1 to R2 can be carried out. Next, third is sequence of operations. The sequence of operations can be specified separated with the comma. But here also T is a control function used. When the T contains the value 1, when the control function contains the value 1, then the operations that are specified after the colon can be executed. Here two micro operations are carried out depending upon the T value. So the value of register R2 is transferred to register R1 and register R1 value is transferred to register R2. So these micro operations are separated with a comma, and T is a control function that can be specified with a colon. When T value is 1, these two micro operations can get executed. In this way, the RTL is used to symbolically represent the micro operations. Next, what is data representation? So, data representation refers to the internal method used to represent various types of data stored on a computer. So, here the registers can hold the values. So, here majorly the types that can be available are numbers, letters, and other discrete symbols. The numbers can be represented with the number system. Generally, the number systems that can be available are binary, octal, hexadecimal. The binary number system can have a base value too. Only 2 digits are available, either 0 or 1. But in case of octal number system, the base value is 8. The digits that can be available in octal number system are 0 to 7. In case of hexadecimal number system, the base value is 16. So here 0 to 9 are digits. Next, capital A to F letters are used to denote the rest of the digits. So by using these number systems, the numbers can be represented in the registers. The letters and other discrete symbols can be represented with the help of ASCII code. So this is the internationally standard code. So American Standard Code for Information Interchange. So this code can be used to represent the letters and discrete symbols. The numbers can be represented by using these three, and also one more code is there, binary coded decimal. By using this code also, the numbers are represented in the computer. So the types of the data types can be represented by using, in case of numbers, the number system, and in case of letters and discrete symbols with the ASCII code. Next, what are second generation computers? The generations of computers generally referred as advancement in the electronic devices that are used for the construction of computer. The advancement in the field of electronics can be reflected in the manufacturing of the computer. So these can be generally treated as generations of computer. Generally, there are 5 generations of computer. The first generation computers generally uses the vacuum tube as major electronic device. But in case of second generation computer, transistors can be used as major electronic device. These transistors are smaller size when compared to the first generation computer. First generation computer uses vacuum tubes, that's why the size can be very large. But it can be greatly reduced with the transistors in case of second generation computers. And because of reduced size, they consumed the less electricity and they generate the less heat, and they are reliable when compared to the first generation computer. But machine language and assembly language can be supported by the second generation computer. To reduce the heat effects of the computer, AC can be required. So IBM 4101 series and Honeywell 400 series are the best examples of the second generation computers. And the layout of the second generation computer is like this. Here are all can be the major electronic components are the transistors. What are third generation computers? The third generation computers uses electronic integrated circuits as the major component. Thousands and hundreds of transistors can be combined and integrated as a IC integrated chip. So the size can be greatly reduced. So these generation, the third generation computers consumed less power and produces less heat. AC can be required for this computer. But these third generation computer support multi-programming operating system. That means the user can capable of executing more than one task at a time by using these third generation computers. And here the third generation computers can support high level language. So the natural language can be used for the development of the programs and applications. The third generation computer are smaller in size, but the speed of processing can be high when compared to the previous generations, and lesser maintenance can be required, more reliable and the cheaper. The third generation computers. Honeywell 2 6000 series, IBM 360 series are the best examples of the third generation computers. What are the fourth generation computer? The fourth generation computers uses the major technique called VLSI, very large scale integration. So here hundreds and thousands of ICs can be integrated in the VLSI technology. So here the size can be greatly reduced in case of fourth generation computer. And here the parallel processing can be possible with the help of pipelining concept, and the fourth generation computers can support internet and time sharing in the computer system. High level languages and procedural languages databases can also be supported by the fourth generation computers, and they are powerful and more reliable than the previous generation computers. They can consume less electricity and produce negligible heat. No AC can be required for these computers. Very small size and portable. These generation computers. PDP-11 and Cray-1 are the examples of the fourth generation computers. What does abbreviation VLSI mean? VLSI means very large scale integration. So here the fourth generation computers uses this VLSI technique. And here thousands and hundreds of integrated chips can be integrated on a single chip with the help of VLSI technology, so that the size of the computer can be greatly reduced. So the VLSI technology can be majorly used in the fourth generation computers. What is meant by processor level? Processor level environment variables indicate the modular number of the CPU installed in the computer, including 8086. So, what are the environment variables that can be available with the CPU depending upon the processor? So that they can vary from processor to processor, from 8086 to 8085 286, 386, like this, depending upon the processor level. These the variables can be varied. They are greatly depending upon the processor architecture. Next, what are the types of a system buses? So, a bus is a communication pathway connecting two or more devices, usually broadcast signals within the computer. So, the communication path that can be established between the devices in a computer is a bus, system bus. The layout of the bus can be generally like this. The system bus can be a combination of three buses. The three buses are address bus, data bus, control bus. These all together, the three buses all together can call system bus. It is a combination of address bus, data bus and control bus. So these are used to connect the processor and the memory subsystem, and input-output devices can be connected with the buses. And here the address bus can hold the address of the memory location where the data can be transferred. The three types of buses that a system bus can comprise of: data bus. Data bus carries the data. So, which is a key determinant performance of the data bus, whether to carry out 8-bit, 16-bit or 32 or 64-bit. So, at the location that is pointed by the address bus, what data has to be read or written can be carried out with the help of data bus. The second bus is address bus. Identify the source or destination of the data. So here the location where the data can be transmitted can be indicated with the help of address bus. CPU needs to read an instruction from a given location in the memory is the example. So the location can be pointed with the help of address bus, and at this location what is the data read can be stored into the data bus. Bus which determines maximum memory capacity of the system. So if it all the bus can be of 4 bits, then it has to locate 2 power 4 locations of the memory. Example, 8080 has 16-bit address bus giving 64K address space. 2 power 16 is 64K. So, the address space can be the 64K. Like this, the address bus holds the location. Next bus is control bus. Control and timing information can be carried out with the help of the control bus. Memory read, memory write, IO read, IO write, transfer acknowledgement. These signals generally transmitted with the help of the control bus. Bus request, bus grant, interrupt request, interrupt acknowledgement are the signals Generally, bus request and bus grant signals can be used to access the DMA controller, and interrupt can be taken and identified with the help of interrupt request and interrupt acknowledgement. Clock and reset signals can be transmitted with the help of the control bus. So system bus is combination of all these three buses. What are the characteristics of the system bus? So here the major parameters that can be considered for the bus is the bus type. The bus type can be whether it is a dedicated or multiplexed. Dedicated means separate data and address lines can be there. Multiplexed means shared lines, address valid or data valid control lines can be used. So depending upon the load of devices that are connected, so the bus type can be decided. Next is bus arbitration. So when more than one module controlling the bus, or only one module may control the bus at a given point of time. Arbitration may be centralized or distributed. So if devices are more than one device are connected, so which device can be actively participate in the communication can be decided with the bus arbitration. Next is timing. So coordination of events on the bus, synchronous or asynchronous. This can be achieved with the clock time or clock signals. If the devices involved in the communication can use the same clock signal, then the synchronous communication can be used. In case of they share the different time signals, then the asynchronous communication can be take place. The bus width of the address bus has an impact on the system capacity. So the address space can be the major impact on the width of the address bus. If address bus bits are k number of bits, then 2 power k locations of the address space can be used. Next is data width. Width of data bus has an impact on system performance. Wider bus means number of bits transmitted at a time. So large number of bits can be transmitted, so the performance can be greatly increased in case of the width of the data bus. Next is data transfer type. Whether the data transfer can be bit type, byte type, word or block type. So these are the parameters majorly considered during the system bus or the characteristic of the system bus. What are different types of interrupts? So interrupt is a signal that can be raised whenever the CPU identifies the occurrence of the interrupt. It has to stop the current program execution. It can suspend the current program execution, and the program control is transferred to the interrupt service routine. The interrupt service routine can be continued the execution one after another instruction in a sequence. At the end, the control again sends back to the main program to continue the main program execution. So these interrupts can be raised with the help of either the software or through hardware. So what are various types of interrupts? Hardware interrupts or software interrupts. In the hardware interrupts, again two categories are available. That is maskable interrupt, non-maskable interrupt. So whenever the CPU executing, for example, this is the main program, and here a collection of instructions are there. The instructions can be executed one after another in a sequence. If there identifies an interrupt, the program can has to shift to the interrupt service routine ISR and the program can be executed here one after another in a sequence. At the end, it has to transfer the control to the main program and resumes execution of the main program. For this purpose, the stack is the efficient data structure that can be used to store the PC address, which will illustrate the return address from the ISR. So the types of interrupts are hardware interrupts and software interrupts. The hardware interrupts is again categorized into maskable interrupt, non-maskable interrupt. What is a hardware interrupt? If a processor receives the interrupt request from an external I/O device, it is termed as hardware interrupt. If input-output devices can acquire the service by raising the interrupt, those interrupts are generally referred as hardware interrupt. Hardware interrupts are further divided into maskable interrupt and non-maskable interrupt. What is maskable interrupt? The hardware interrupt that can be ignored or delayed for some time if the processor is executing a program with higher priority are termed as maskable interrupt. When the processor is executing an higher priority program, during that time an interrupt is raised, it can be ignored or it can be delayed for some time. That type of interrupts are called as maskable interrupt. The second variety is non-maskable interrupt. The hardware interrupts that can neither be ignored nor delayed, okay, and must immediately be serviced by the processor are termed as non-maskable interrupt. So, immediate service needed interrupts can be the non-maskable interrupt. Next, the second category of interrupt are the software interrupt. The software interrupts are the interrupts that occur when a condition is met or during a system call. Generally, the system calls exceptions raised with the programs are examples of the software interrupts. Next, state EDVAC. So, it is EDVAC. The full form of EDVAC is Electronic Discrete Automatic Computer. Electronic Discrete Variable Automatic Computer. It is a first generation computer. The example of first generation computers are ENIAC and EDVAC. So, here it is used by the US Army between 1947 to 1950. So, it is a first generation computer. The basic electronic device that can be used in the EDVAC is the vacuum tube. So, the size can be very large and more heat can be generated with the help of this device. And it is the best example for the first generation computers. Define fixed point number. So, a fixed point number has a specific number of bits or digits reserved for the integer part. Okay, and a specific number of bits reserved for the fractional part. So, here these are called the fixed point number. What is floating point? Floating point, as the name implies, these numbers that contain the floating decimal points. Generally, in a system, IEEE formats can be used to represent the floating points in a scientific notation. Define instruction format. Generally, the program is collection of instructions written for a specific objective. So, each instruction can be specified with the instruction format. Each instruction can be divided into The instruction format consists of two parts. One is the opcode, the second one is the operand. Opcode is used to represent the micro operation what is to be performed on the specified operand. So here the effective address of operand can be specified here. A variety of ways to specify the address or operand here. So here immediate mode, register mode, direct mode, indirect addressing mode, variety of addressing modes we have to use to denote the operand effective address here in the operand or address part of the instruction. The opcode is generally used to specify the micro operation what is to be performed, like add, sub, mul, like that. What a micro operation can be used on this address can be specified with the opcode. And the last MSB bit of the instruction is generally used to specify the addressing mode. Two types of addressing modes are generally used here and is denoted with a letter I. When I is 0, it is a direct addressing mode. So whatever the address specified here address part, at that the operand can be available. That we can refer as the direct addressing mode. When I value is equal to 1, then it is a indirect addressing mode. What is the operand address specified here? It is effective address of the operand. Another memory cycle can be required to fetch the actual operand from the memory. So, two cycles are required to access the operand in case of indirect addressing mode. So, here generally the 0 to 11 bits has to be used to specify the address. The next 3 bits can be used to specify the opcode. The 15th bit is used to represent the I value. So, depending upon this instruction format, various basic instruction formats that can be available are memory reference instruction, register reference instruction, input output instruction. So depending upon the opcode and I value, the categories of instructions can be easily identified. In case of memory reference instruction, the opcode can be ranged between 000 to 110. Those instructions are generally comes under the category of memory referenced instructions. When the opcode is 111, I value is 0, then those instructions are considered as register referenced instructions. The third category is when the opcode is 111, I value is equal to 1, those comes under the category of input output instructions. Next, define the data processing instruction. The another name of these data processing instructions are data manipulation instructions. They are generally used to perform operations on data and provide computational capability for the compiler. So here these data processing instructions generally process the data and the computational capacity and the decision making capacity can be provided to the compiler with the help of these data processing instructions. There are 3 categories of data manipulation instructions: arithmetic instruction, logical and bit manipulation instruction, shift instruction. Arithmetic instructions are generally used to perform the arithmetic operations like addition, subtraction, multiplication and division. To support this, the various mnemonics that can be available in arithmetic instructions are add, sub, mul, like that. And the second variety of data processing instructions are logical and bit manipulation instructions. So the register bits can be used to manipulate here. and the decision making capacity can be provided to the computer with the help of logical and bit manipulation instructions. The general category of these instructions are AND, OR, XOR. All these comes under the category of logical or bit manipulation instructions. The third variety of instruction is shift instruction. So serial communication, serial transmission can be possible with the shift operation. Two types of shifts are generally used by the direction, left shift and right shift. And three varieties of shifts are available: logical shift, arithmetic shift, circular shift. So here the general varieties of shift operations are ROL, ROR, SHL, SHR, like this. So these are the basic varieties of data processing instructions. Next, define data storage. Since data processing operations are normally performed on the data in the CPU register, data storage can be needed. So the memory unit provides the data storage, and to facilitate the speed of accessing during arithmetic and logical operations, registers can be used for the data storage operation, so that the data can be readily available to the ALU, so that the speed of processing can be increased. Define data movement instructions. The data movement instructions, the another way we can refer with the data transfer instruction. The data transfer instruction generally move or transfer the data from one place in the computer to other place without changing the data content. So the most common transfers are involved between memory and processor registers, between processor registers and input output, between processor and registers itself. General typical list of data movement instructions that can be used are load. The load can be supported with a mnemonic LD. Store. Store is used with a mnemonic SD. To make a move or transfer MOV. To swap the values between the register, exchange XCH is the mnemonic. To perform the stack operations, push PUSH to insert a value on the top of the stack, and pop to retrieve value from the top of the stack. Input IN and output OE2. These are the list of data transfer instructions. The in and out facilitate the data transfer between the IO devices. Define control flow instructions. The control flow instructions, in other way referred as program control instructions. These instructions are generally used to alter the flow of execution of the program. So, to specify the conditions for altering the content of the PC, while data transfer and manipulation instructions specify the conditions for data processing operations. The change in the value of the PC, as a result, the execution of the program can be altered. So these instructions provide control over the flow of program execution and capability of branching to different program segments. What are the list of control flow instructions? Branch. Branch is used with a mnemonic BR, jump, JMP. So branch and jump are generally used unconditionally, can transfer the flow of, alter the flow of execution. Next, skip next, SKP. Next, call procedure, CALL. Written from procedure, RET. Subroutines or procedures can be called with a call mnemonic, and from thereafter the control to the return to the main program with the RET mnemonic. Compare, CMP. Test, TEST. So here the test can be performed. The conditional branching can be activated with the help of the status register bits. 4 status register bits are generally used. Z is used to represent the 0, C is for carry, V for overflow, and S for sign bit. The examples of the program control instructions is branched to the specific address. Jump again is a label, user specified label. Escape, skip to the next instruction. Call the required function. So CALL function 1. Return to the main program. Compare CMPs R1, 0. Test R1, R2. So in this way, the program control instructions can be used in the development of the assembly language programs. So these are the definitions and terms related to the module 1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.